This is problem 31 from chapter 16 of the textbook Stats Modeling the World, second edition. Okay, so we're looking at sort of insurance, homeowners insurance policy problem. So an insurance company estimates that it should make an annual profit of $150 on each homeowner's policy written, with a standard deviation of 600. So then we would say sort of the expected value of X is 150, and the standard deviation of X, one policy, is 6,000, where I guess X is the profit, of one policy. Okay, so first question, why is the standard deviation so large? Well, it's large because basically what happens is there are many policies with small profits, but a few policies with very large losses, because they have to pay out a claim on if a house gets completely destroyed. That can be very expensive. So they're only making $150 per home. That's not very much profit, so they have to sell lots of policies, and then it adds up to something significant. But when a house burns down or something like that, catastrophic happens, there's a big payout. So a lot of times we have a mean that's much bigger than the standard deviation. Here the standard deviation is much larger than the actual expected value. Okay, so I hope that helps. Let's move on, do some computations. So if they write only two policies, what's the expected value and standard deviation? So that would be the expected value of x1 plus x2. So that's just going to be 2 times the expected value of x. So 2 times 150 is $300. So then the variance of x1 plus x2 is just the variance of x plus the variance of x. So that's going to be 6,000 squared plus 6,000 squared. So 6,000 squared times 2 equals, we're in insurance land, so big numbers, 7-2 with 1, 2, 3, 4, 5, 6 zeros. So 7, 2, 1, 2, 3, 1, 2, 3. Okay, and then the square, so the standard deviation of x1 plus x2 is just the square root of that. So that's going to be 8485 Okay, 8485. Okay, so I guess I could add the cents if you want, but $8,485 essentially for two. So that's two policies. Okay, so now C is 1,000 policies. So it's pretty much the same computation. X1 plus X2 plus, and this is how I deal with this, plus X 1,000. And again, the reason I write this out is because each policy is a separate event. Okay, so that's going to be 1,000 times, I'm losing it here, the expected value of X, so that's 1,000 times 150, so that's going to be a lot more zeros. Okay, so now we're talking big bucks. Okay, so now what's the variance? Well, the variance of X1 plus X2, whoa, what happened? X2 plus X, or excuse me, that's not going to work. Dot, 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 plus X 1,000 is just 1,000 times the variance of X. So that's 1,000 times 6,000 squared. And so the standard deviation of X1 plus X2 plus dot 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 X 1,000 is just the square root of that. And that comes out to be, at least when I did it, I get 600,000. Okay, so now with 1,000, so now look, the standard deviation is much smaller. Well, no, it's bigger, but it's definitely smaller than the expected value. Okay, so let's see. There's a couple follow-on questions. So I'm not sure if I can write it out, but I can talk through it. Do you think the company is likely to be profitable? So I would say definitely yes if they sell 1,000 policies. Because you know, if you look at the expected value, to get to 0, you'd have to go minus 1 standard deviation, minus another standard deviation, and then half a standard deviation. So you'd have to go minus 2.5 standard deviations in order to get to 0. So that's quite a ways away. Okay. Now, however, probably no if they only only sell 2 policies, because what was the mean? The mean was only $300. So the expected value, actually, let's not use that notation. Expected value of X. So here's the expected value of X. It's only $300, but the standard deviation is huge, right? The standard deviation was 8.48.28, 485.28. So $300 or zero is real close. If this is one standard deviation away, zero is real close. I'm even, so it's just barely a fraction of one standard deviation. So it's highly likely that you could hit zero. So anyway, that's one way of answering D. Let's see. C was what assumptions underline your analysis? Well, each policy is independent. Okay, and then they want to know, can you think of circumstances under which those assumptions might be violated? So probably there what we're thinking about is some kind of natural some kind of natural disaster. So like a forest fire, or we're having all kinds now, a real bad tornado that comes through, or a hurricane, something like that, where all the houses get destroyed and they all have to file a claim. Then the policies could no longer be perceived as independent. Okay, so there you go. That's one approach to this problem. If you have a slightly different answer, I think that might be okay as long as the concepts are pretty sound. The computations, though, there's no alternative answer to the computations. These are them. Good luck.